Good morning, dear students. Today's topic is aromaticity. We are going to discuss about what is the importance of aromaticity, why aromatic compounds are more stable than aliphatic compounds, then the distinguish between aromatic compounds, anti-aromatic compounds, and non-aromatic compounds. Then the classification of aromatic compounds based on the nature of benzene derivatives are going to discuss. First, we will discuss about what is aromatic compound, what is aliphatic compound with the structures. Let's say I will start with very basic example like benzene. Because if we talk about aromatic compound, we will start with the basic example with the benzene. Benzene, the basic aromatic compounds. The molecular structure formula is C6H6. C6H6. Whereas its precursor means the 6 carbons, I will write one more structure of the aliphatic compound. Six carbons with alternative double bonds. This is 1, 3, 5 hexatriene. The IUPAC name of the compound is 1, 3, 5 hexatriene. So it contains three double bonds. The double bonds are located in the alternative pattern. So if you write the molecular formula C6H 2, 3, 4, 5, 6 to 8 H8. So among these two, one compound is aromatic compound, one compound is aliphatic compounds. Here see, conjugation is present in this compound like benzene. Conjugation is also present in this compound. Conjugation means alternative double bonds. Right? So now we think about the delocalization. So here the delocalization of the pi electrons taking place if you find the conjugated double bonds. In the benzene structure, we have 3 double bonds which are arranged in the alternative pattern, whereas in the 135 hexatriene also we have 3 double bonds which are arranged in conjugated alternative pattern. So here in the benzene 3 double bonds means 6 pi electrons, whereas in the 135 hexatriene also we have 6 pi electrons. Here it contains 6 pi electrons, means one double bond. One bond is equal to 2 electrons. So 3 double bond means 6 pi electrons. Here also 6 pi electrons it contains. Now if the double bonds are in the conjugated positions, these pi electrons must be delocalized. Let's say I have 1, 2, 3, 4, 5, 6. Initially the double bond between the 1, 2, 3, 4 and 5, 6 carbons between. In the delocalizations, the positions of the double bond will be changed from 2 to 3, 4 to 5 and 1 to 6. Means the delocalization of the pi electrons are taking place, means the pi electrons are equally shared by the all carbons. Delocalization is observed. delocalization is observed in the case of the benzene. Now see here in the hexatriene also here what happens, the double bond is shifting from 1 to 2 in between 1 to 2 to 2 to 3, then whereas like this. Here also what happens, the delocalization is observed. Delocalization also observed in the case of the 135 hexatriene. But here in the case the delocalization is continuous, like cyclic manner. Means starts with 1 and ends with 6 at first pattern, and next like that what happens, the delocalization is not stopping at any point, that is cyclization, that is continuous of the delocalization is taking place. This continuous delocalization leads to resonance. As the resonance increases, the number of resonating structures increases. As the resonating structures increases, stability increases. Coming to this also, what happens here? The electrons are transferring from 1 to 6, and the electrons are transferring from 1 to 6, and the electron transferring from 6 to 1 is not observed because this is non-cyclic, which is also called as acyclic, which leads to resonance. Resonance is also possible, but the number of resonating structures leads to only two resonating structures. This is the one and other one is the 2, which leads less number of resonating structures compared to the benzene. As the less number of resonating structures, stability decreases. Right? So, resonance is possible in the both cases, but extent or severe or more resonance is possible in the case of benzene. The reason is cyclic in nature. Means cyclic compounds will produce more resonance than the acyclic compounds. Such type of compounds are called as aliphatic compounds. And the compounds which are conjugated delocalized pi bonds with cyclic structures, and those are generally classified as aromatic compounds. Right? So aliphatic compounds and aromatic compounds. Always aromatic compounds are more stable than the aliphatic compounds. That is due to the resonance. Next, conditions. What are the conditions required for the aromaticity? Is this enough, like cyclic structure, delocalization, etc.? Now we discuss about the conditions required for the aromatic compounds. Conditions required to be aromatic. What are the conditions a substance or a molecule or a compound need to satisfy if it is attains aromaticity. To attain aromaticity, a compound must satisfy the following conditions. The condition number one, the compound must be cyclic. The compound must be cyclic. The condition number two, the compound must be conjugated compound. Condition number three, it must be planar. When it is planar, if all the atoms of the that compound must contain the sp2 hybridization. Next four, it must follow 4 and 2 pi electrons rule. 4 and 2 pi electrons rule. These are the conditions must satisfy a compound if it is said to be aromatic. Any compound fail to satisfy any one of these four conditions said to be non-aromatic. Each and every compound must satisfy these four conditions. So I will explain that with example. Right? So generally this was given by the Huckles. That is called as the Huckles rules. According to Huckles, the compound is cyclic in nature, must having the delocalized pi electrons, that is a conjugation, with a planar molecule, and must contain the Huckel number. What is the Huckel number? 4n plus 2 pi rule, where n is a whole number, 0, 1, 2, 3, 4, etc. I will substitute the different n values in the 4n plus 2 pi. The first case, if it is n is equal to 0, then 4, 0 plus 2 pi is equal to, whereas 4 into 0 is 0 plus 2 pi, then the 2 pi electrons. If it is equal to 1, then 4 into 1 plus 2 pi electrons, then it gives 6 pi electrons. Then n is equal to 2, then it gives, if substitute 2 here, 10 pi electrons. If n is equal to 3, it gives here 3, 14 pi electrons, so on. We have to substitute the different n values starting from the 0 in the given equation, and finally we will get like 2 pi electrons, 6 pi electrons, 10 pi electrons and 14 pi electrons. Means your compound must contain the pi electrons and that number must match among any one of these Huckel's number. I will start with an example like benzene. Our well-known example is benzene. Right. Here the benzene molecules, so we will go conditions one by one. It is cyclic in nature because it is a cyclic structure. Benzene is a cyclic structure. The first condition is fine. The second condition is conjugated, alternate double bonds, therefore delocalization is also there. That is fine. The third condition is planar. If the carbon skeleton is in the conjugated system, then obviously all the carbons are in the sp2 hybridization, because this is the carbon and this is the carbon. Let's say we are having the 1, 2, 3, 4 bonds and one hydrogen for the each one. C6H6. Right? 1 bond, 2 bond, 3 bonds. Only sigma bonds will be calculated for the hybridization. Therefore, it is sp2, 1 s orbitals, 2 p orbitals, like that. All the carbon atoms are sp2 hybridized. So once all the carbons are the sp2 hybridized, the structure is planar structure. So it is planar in nature. And finally, whether it is satisfy the Huckel's rule or not, it contains the three double bonds into 2 electrons, because one bond is gives 2 electrons, 6 pi electrons. So benzene having 6 pi electrons. Yes, that is the Huckel's number. 6 pi electrons is there. Once the benzene is satisfying all these conditions, all those 4 conditions, therefore benzene is a aromatic compound. Benzene is a aromatic compound, right? So therefore benzene is a basic aromatic compound. Benzene, if we talk about aromatic compounds, we'll start with the benzene. So that is a base for aromatic compound, aromatics, right? So I will read some more examples like, so this is the naphthalene. It is also benzene derivatives. 2 benzene rings are fused. So now, so obviously it is a cyclic in nature because the cyclic structure. The conjugation is also there. Alternate double bonds are there. So conjugation. Once it is conjugation skeleton, obviously planar in nature because all the carbon atoms of that molecule is sp2 hybridized. sp2 hybridized. The last one is we need to focus on the Huckel's number. First count on the double bonds. We have 5 double bonds. So each double bond is 2 electrons, therefore 10 pi electrons. So our number is 10 pi electrons, therefore it is satisfying all conditions, therefore it is aromatic compound, right? One more example is naphthalene. 3 benzene rings are fused. The naphthalene, 3 benzene rings are fused, right? So the condition number 1 is cyclic, condition number is the delocalization or the conjugation, the planarity because due to the conjugation, and the final one is Huckel's number. So count on the double bonds, 3 to 5 to 7 double bonds into 2, 14 pi electrons, 14 pi electrons, therefore aromatic. Therefore aromatic. Name of the compound is, name of the compound is anthracene. Anthracene. Like that, we have to classify, we have to distinguish the given compound is aromatic, anti-aromatic, or the non-aromatic. So among all these, aromatic compounds are more stable because aromatic compounds having the lowest energy and having the more resonance, right? Then move to the next slide. So I will use some more example for that. Three types of the compounds. So all the compounds having the 3 carbons. So 3 carbons means pro. The structure is cyclo. The name is cyclopropene. The first compound. The second compound cyclopropenyl cation. Cyclopropenyl cation. So prop double bond is there. That's why ene is there. Cyclopropene. Same cyclopropene with the cation, cyclopropanyl cation. This is cyclopropanyl anion. Cyclopropanyl anion. Cyclopropene, cyclopropanyl cation, and cyclopropanyl anion. Now we have to discuss the aromatic behavior of all these three compounds. We'll go one by one. First, the cyclopropene. Cyclopropene, the first condition is, see, we have to the cyclic or non-cyclic. It is a cyclic compound, right? That is good. It is cyclic compound. Second one is, we have to see conjugation is there or not. Conjugation is there or not. Here, see, the double bond is shifted here and there is no continuation. There is no alternate double bonds and there is no delocalization of the electrons is taking place. The delocalization is possible when one double bond is in conjugate with a double bond, or when a double bond is in conjugate with a lone pair, or like this. A double bond must be conjugate with a double bond, then the delocalization is possible, or a double bond must in conjugation with a lone pair, let's say oxygen, like this, or when a double bond is in conjugation with the charge, either positive or negative charge. So these are the conditions generally we need to observe, then only the delocalization is possible, right? Here such a type of conditions will not be observed in the case 1, means no conjugation. No conjugation. If there is no conjugation, this particular carbon atom is sp3 hybridized. Means, so not a planar, no planarity. No planarity. Because when it is said to be planar, all the carbon atoms of that particular compound must having the sp2 hybridization. But here we are observing that due to the lack of the conjugation, the particular rounded carbon is sp3 hybridized. sp3 hybridized is a tetrahedral, right? No planarity. And the final condition is the pi bond. We have only one pi bond. So let's say it is the 2 pi electrons, even though it is a Huckel's number, but it is failing these two conditions. When a molecule is said to be aromatic, it must satisfy all the 4 conditions. There is no any exception among those. Must satisfy the 4 conditions. Therefore, this is non-aromatic or not aromatic. Non-aromatic. Because fail to satisfy the condition number 2 and condition number 3. Even though it having a Huckel number. Even though it having a Huckel number. So, cannot be considered as aromatic compound. Then coming to the cyclopropanyl cation. The first one is obviously satisfied, that is a cyclic in structure. That is the cyclic structure. So there is no end for the point. Always delocalization is taking place in the cyclic manner. Now here we have a delocalization because the positive charge is in the conjugation with the double bond. Therefore, conjugation will be observed once is the delocalization. Delocalization is observed, right? The condition number 3, once it is the conjugation is observed, that is a planar compound, all the carbons of that particular compound is sp2 hybridized. sp2 hybridized. And the fourth one, we have to see, so if a positive charge will be observed in a given compound, we will consider 0 electrons because the positive charge is the deficient compound. It requires electrons. It is not having any electrons, right? So 0 electrons. Therefore, one double bond we have. One double bond into 2 is equal to 2 pi electrons. This is a Huckel's number, right? So cyclopropanyl cation is satisfying all the 4 conditions. It is cyclic in nature. Delocalization of the electrons is observed. The planar molecule and having the Huckel's number. Therefore, said to be aromatic. Therefore, it's said to be aromatic. Right? Okay. And the final one is the cyclopropenyl anion. Cyclopropenyl anion. The first condition is cyclic in nature. That is absorbed because the structure, by seeing the structure, we can say whether it is a cyclic or not. The second one is conjugation, the delocalization. Delocalization is observed because the negative charge is in the conjugation of the double bond. So once it is conjugated, that is the planar compound. Planar, obviously. The fourth one is we have to see whether it is a Huckel's number or not. So now see, we have to consider the two electrons for the negative charge. Anion is the electron excess can able to donate a pair of electrons. Therefore, we have one double bond and the negative charge will also be considered as a double bond. So, two double bonds into two electrons, that is 4 pi electrons. 4 pi electron is not a Huckel's number, but it is satisfying first three conditions and it is not obeying the Huckel's number. So, therefore, it is called as anti-aromatic in nature. Anti-aromatic in nature. It is satisfying all the three conditions except the Huckel's number. Therefore, it is called as the anti-aromatic. Now, we will define what is a non-aromatic compound. The compound which fail to, which deviate any one of the four conditions. Any one of the four conditions. Such type of compounds can be classified as non-aromatic compounds. So aromatic compounds means which satisfy all the conditions, including the Huckel numbers. That is called as the aromatic. Anti-aromatic compounds which satisfy first three conditions and having 4n pi electrons. 4n pi electrons. This is 4n 2 pi electrons, whereas it is having 4n pi electrons. That is the difference between the aromatic and anti-aromatic compounds. Aromatic and anti-aromatic compounds. Aromatic compound having the 4n plus 2 pi electrons. Anti-aromatic compounds are having the 4n pi electrons. Similarly, n is equal to 0, 1, 2, 3, etc. So, if n is equal to 0, then it is 0 pi electrons, because if n is equal to 1, 4 pi electrons, see here 4 pi electrons. If n is equal to 2, 8 pi electrons. If n is equal to 3, 12 pi electrons, right? Like this we have to discuss. So, from this we have to identify which is a non-aromatic compound, aromatic compound or anti-aromatic compound, right? One more thing we have to observe that in between the aromatic and anti-aromatic compounds, the aromatic compounds are having odd number of double bonds in the given compound. The aromatic compound are having the odd number of the double bonds in the given compound, whereas the anti-aromatic compound are having the even number of double bonds. Except these two conditions, the remaining conditions are the similar. First three conditions will be satisfied by the both type of the compounds, right? So in the second, after satisfying with the first three conditions and the fourth conditions, if the molecule are having the odd number of double bonds, then it is the aromatic. If the molecule having the even number of double bonds, then it is said to be aromatic. If any compound fail to one of the four conditions, then it comes under the non-aromatic compounds, right? Next, we will discuss some more examples. The first one is So it is cyclobutadiene. The name of the compound is cyclobutadiene because it is having the four carbons. It is having the four carbons. That's why but. It is a cyclic in nature. Cyclo. Next, diene. It is having the two double bonds. Therefore, diene. Double bond means ene. Right. We will discuss the conditions. First is cyclic. That is obvious. Cyclic in nature. The second one is conjugated double bond because double bond, single bond, double bond, a single bond. You may be write as a square, as a rectangle, no worry. Cyclic. So conjugation is present, means the delocalization is there. Once it is satisfied, planar. How many double bonds? Two double bonds. Two double bonds means even number. Two double bond is even number. So therefore cyclobutadiene is anti-aromatic in nature. Cyclobutadiene is anti-aromatic in nature. Next, second example. This is cyclopentadiene. Cyclic structure, 5 carbons penta, 2 double bonds diene. 2 double bonds diene. So, cyclic structure, we have to see conjugation is present or not. So, double bond, single bond, and a single bond. The conjugation means alternative double bond. The conjugation or the delocalization occurs from this point to this point. Delocalization will be observed from, let's say, carbon number 1, 2, 3, 4. The fifth carbon is not at all involved in the delocalization because the fifth carbon is not comes under the conjugated double bond. Therefore, this is sp3 hybridizer. There is no conjugation and non-planar. So then no need to go for the Huckel's number. Once the first three conditions, one conditions fail to attempt or satisfy, then obviously this is non-aromatic compound. Next, the derivative of the cyclopentadiene. Cyclopentadienyl cation. Because cyclic structure cyclo, 5 carbons penta, 2 double bonds diene, and a positive charge cation. Now see delocalization start from the carbon 1 and here, right? So 1, 2, 3, 4, 5. So delocalization is circulated in all type of the manner. So cyclic is fine. Then conjugation is there because the delocalization is taking place throughout the ring. The third one is the conjugation means planar compound. The fourth one is we have to see. The first three conditions are satisfied. So now the number of the double bonds. If it is a positive charge, it cannot be considered as a double bond as it providing 0 electrons. Therefore, two double bonds. Two double bonds means even. Therefore, cyclopentadienyl cation is anti-aromatic. anti-aromatic. Right? Next. Fourth one, cyclopentadienyl anion. So previously we discussed about the cation. Now we discussed about the anion. Right? So cyclic structure, 2 double bonds, 5 carbons with a anion, negative charge. Cyclic conjugation is there because, right, throughout the ring. So conjugation is there. So once that is a conjugated molecule, so that is a planar in structure. So all the three conditions are satisfied. Now count the double bonds. I already told you that if you find a negative charge, treat it as a double bond. So therefore, 3 double bonds, odd number. Therefore, cyclopentadienyl anion is aromatic. Means cyclopentadiene is non-aromatic. Cyclopentadienyl cation is anti-aromatic. Cyclopentadienyl anion is aromatic in nature. Example number 5. Cycloheptatriene. Next example is cycloheptatriene. Means cyclic structure. Hepta means 7 carbons. Triene means 3 double bonds. Right? The structure will be like this. Right? So this is the structure of the cycloheptatriene. Cyclic structure with 7 carbons. 1, 2, 3, 4, 5, 6, 7 and 3 double bonds. Right? So we will look into the conditions. First one is the cyclic, that is obviously the conjugation. See here. So conjugation starts at 2, ends at 7. The one is not involved in the conjugation, and there is no conjugation means that is non-planar. So structure, the carbon number 1 is out of plane. So cyclic, conjugation is not there, non-planar. So it failed to satisfy the 2 conditions. Therefore, it is non-aromatic in nature. Non-aromatic in nature. Sixth one. Cycloheptatriene cation. Cycloheptatriene cation. So then same structure with a positive charge. Same structure with a positive charge. Right? So now the delocalization will be possible. Right? The delocalization will be possible. So therefore, cyclic, conjugated, planar. These 3 conditions are satisfied obviously. Next one is double bonds. How many double bonds we have? The positive charge is 0. 3 double bonds. 3 means odd number. So once it contains the odd number of the double bonds with satisfying above 3 conditions. Therefore, it is a aromatic compound. If I write the 7 one with anion, so that is cyclic, conjugated, because conjugation is there. So positive or negative charge, you have to consider the conjugation. Cyclic, conjugated, planar, 4 double bonds. 4 means even number. Even means anti-aromatic. Anti-aromatic. Next. The one more best example is one type of example on heterocyclic compounds. Heterocyclic compounds. Heterocyclic compounds like pyrrole, furan, thiophene. Pyrrole, furan, thiophene. So these are the 5-membered heterocyclic compounds. Heterocyclic compounds means different type of the atoms of cyclic content. See here, this is carbon, this is carbon, this is carbon, this is carbon, but this is the nitrogen. Two different types of the atoms are involved in the formation of a cycle. Therefore, it is called as a heterocyclic compound. So far, we discussed about the homocyclic compounds because the cyclic consists of all the carbon atoms. So in this case, also see here. So we have for in each structure, all of the 5-membered structure. Here it is contain the nitrogen and it contain oxygen and containing sulfur. All these 3 atoms are having a lone pair. Lone pair is also considered for the conjugation. It is delocalization is present in all the 3 conditions. So therefore, for all these 3 molecules, the condition number 1 is cyclic. Condition number 2 is conjugation, because conjugation is there. See here, this double. So this lone pair delocalized here, this pi bond delocalized here, this pi bond delocalized here. Means the pi electrons are delocalized throughout all the atoms of the cycle. All the atoms of the cycle. So therefore, conjugation is possible in all the 3 compounds. Conjugation is there. Once it is a conjugation, that is planar molecule. So in all the cases, what happens? How many number of the double bonds? 2 double bonds. 2 double bonds plus 1 lone pair. So overall, how many? We have 3 double bonds. 3 double bonds. So 1 lone pair is involving, 1 lone pair is involving, 1 lone pair involving. Don't consider this lone pair because these lone pairs are present out of the ring. These lone pairs are present out of the ring. That's why. So 2 double bonds and 1 lone pair. So how many double bonds? 3 double bonds. 3 double bonds means odd number. Odd number means aromatic. Aromatic compounds. Therefore, pyrrole, furan, thiophene are aromatic compounds of heterocyclic group. Aromatic compounds of heterocyclic group. One more heterocyclic group is there. The name of the compound is pyridine. Pyridine. It resembles benzene. It resembles benzene. But in the benzene, what happens? All the carbon atoms are there. Instead of the carbon atoms, C5, H5N. This is C6H6. Right? 1 carbon is replaced with the nitrogen. 1 carbon replaced with the nitrogen. So therefore, see here, cyclic structure delocalization is observed. So all this cyclic, conjugation, planar. How many double bonds? So lone pair, don't count this lone pair. This lone pair is out of the cycle. So 3 double bonds. 3 double bonds means odd number. Odd number means aromatic. Odd number means aromatic, right? So this is the pyridine. So these all are comes under the heterocyclic compounds and aromatic compounds. The last example we need to focus on under the aromatic character. The important example is cyclooctatetraene. Cyclooctatetraene. Right? Cyclo means cyclic structure, octa means 8 carbons, tetraene means 4 double bonds. Right? 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons with cyclic structure. Double bonds, alternative. 1, 2, 3, 4. 1, 2, 3, 4. So go for the conditions. First one is cyclic. Second one is conjugation. Conjugation is there. Alternate double bonds is there. Right? Conjugation is there. So once is conjugation, it is a planar compound, planar molecule. So count the number of double bonds. 4 double bonds. It is even supposed to anti-aromatic compound. Anti-aromatic compound. So according to our discussion from the starting of the aromaticity is that if a compound satisfies the 3 conditions and having the even number of the double bonds, that can be comes under the classification of the anti-aromatic compounds. According to that discussion, cyclooctatetraene is a anti-aromatic compound, but practically that is not anti-aromatic compound. The cyclooctatetraene is non-aromatic compound. Non-aromatic compound because this is highly energetic. This cyclooctatetraene is highly energetic, less stable. So due to its more energy, this is generally exist in a tub-shaped structure, not like this structure. A tub-shaped structure, right? 1, 2, 3, 4, 5, 6, 7, 8. Double bond, alternative double bonds. Once the cyclooctatetraene is turns to the tub state. Why it is converting into tub-shaped structure means this is less energetic. This is less energetic. And the next one is once it is a less energetic and it is more stable. Due to its stability, the cyclooctatetraene is exist in the tub structure. So what if it is substructure? So what happens? Why it is losing its anti-aromatic character means here the angle between the any carbons, that is 120 degrees sp2 hybridization. The 120 degree leads to the planar. Whereas due to the stretching here, that is 135 degrees generally it was observed in the stretches. 135. 135 degrees means that is deviating from the planarity. Deviating from the planarity. So due to its conversion from the less stable structure to the more stable structure, it is going to lose its planarity. That means non-planar. I already told you that if any compound fail to satisfy at least one of the condition among 4, that is said to be non-aromatic. So this is very important example in the point of examinations. Because everybody think that cyclooctatetraene is a. The final topic is classification of aromatic compounds. The classification of aromatic compounds. This classification is purely depending on the nature of the benzene derivatives. This classification is mainly depend on the benzene derivatives because So if the aromaticity is beginning with the benzene, so if benzene will be considered as the basic aromatic compounds, right? So therefore benzene referred to as aromatic compound based on its nature and based on the nature of the benzene derivatives. Generally the aromatic compounds are classified into two types. So A is benzenide aromatic compound, benzenide aromatic compounds. B is non-benzenide aromatic compound. B is non-benzenide aromatic compounds. So now we will discuss what is benzenide aromatic compound and later what is non-benzenide aromatic compound. First we will discuss about the benzenide aromatic compound. Right? Okay. So it is very simple to define a class of aromatic compounds which contains at least one benzene ring. Contain at least one benzene ring. A class of aromatic compounds which contain at least one benzene ring. Which contains at least one benzene ring. Right? So those are called as the benzenide aromatic compounds. Benzenide aromatic compounds. The benzene may be exist in the isolated benzene or more benzene rings. I mean 2-3 benzene rings are fused. Let's say example. So example is, so I can write benzene. I can write benzene. It is an aromatic compound because it contains a benzene ring. This is the monocyclic. This is the monocyclic. Then I will write 2 benzene rings fused. 2 benzene rings fused because the benzenide aromatic compounds contains at least one benzene ring. At least one benzene ring. Means 6-membered ring it contains. It must having the 6-membered ring at least one. So 2 benzene rings are fused. Therefore, it is generally called as the naphthalene. Naphthalene. This is a bicyclic because 2 benzene rings are present. If I write 3 benzene rings are fused, 3 benzene rings are fused. This is anthracene. Anthracene, that is a tricyclic. Right? So benzenide aromatic compound. So you can write isolated benzene. It is a benzenide aromatic compounds. Naphthalene, a bicyclic benzenide aromatic compounds. Anthracene, a tricyclic benzenide aromatic compound. You can simply write this. Pyridine. It is having a benzene structure, a 6-membered structure. So therefore, pyridine is also comes under the benzenide aromatic compounds because it is a 6-membered aromatic compound. So pyridine comes under the benzenide aromatic compounds. Next, B, non-benzenide aromatic compound. Non-benzenide aromatic compound is the second classification of the aromatic compound. So this is also same. A class of aromatic compounds which do not having a benzene ring. Not having benzene ring. There it must having the benzene ring at least. Here there is no presence of the benzene ring. So therefore these class of non-benzenide aromatic compounds are other than 6-membered. other than 6-membered. Generally, these non-benzene aromatic compounds are 5-membered or 7-membered rings or both fused. Isolated 5-membered గా, isolated 7 members or the fusion of the 5-membered or the 7-membered. So those are classified as the benzene ring. So non-benzenate. If I take the 5-membered, pyrrole is an aromatic compound that is not a 6-membered ring, 5-membered ring. Furan is also a non-benzenide aromatic. Thiophene is also a non-benzenate aromatic compound. Cycloheptatriene. Cycloheptatriene is an aromatic compound, but this is a 7-membered. So therefore, this is also comes under the non-benzenate aromatic compound. So if it is an isolated 5 members and this is the 7-membered, these all comes under the non-benzenate aromatic compounds. I will give one more example for the fuse of the 7 and 5. Right? The name of the compound is azulene. It is having the cyclic structure, conjugated, planar, and having the even odd number of the pi bonds. Cyclic, conjugated, planar, 5 double bonds, odd, aromatic. This is 7-membered, this is 5-membered, this is fused. Therefore, the second one also comes under the non-benzenate aromatic compound. So this is about the classification, etc. So today we focused, means we completed the aromaticity concept. Here in the examination point of view also, generally they will ask like that what is the Huckel's rule, and they will give some compounds or the molecules and you have to classify whether it is the aromatic compound, anti-aromatic compound or non-aromatic compound, and finally they may ask a question based on the classification also. Right? So that's it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.